we have Mark Suter, a computer science instructor, and he's going to be talking kind of about the connections to computer science and gaming. He is a computer science, game design, and entrepreneurship teacher for 14 years. And as he calls it in his bio here, he says that his classroom is a hybrid of a mad scientist laboratory and a traveling circus. So I'm very excited to see where this presentation is going to go.
Already intrigued.
Yeah, I know. He is the director of a student-run business called grit9.com. And he also provides web design services for area businesses. So he kind of does a little bit of everything, which is something I've noticed with a lot of our presenters today. They've consistently had their hands in a lot of different projects, which is pretty interesting to me. And what he's going to be talking about, just a brief synopsis, is that he's going to be talking about creating VR training simulations. So kind of creating VR type programs in Unity, and then showing how they can be used in both games and maybe in the real life as well, which is really exciting. I love bridges between like virtual reality and real life. I feel like eventually that's where I want technology to go in the future. It's going to be great.
Mm-hmm. Absolutely. And I'm looking forward to this presentation here. So let's give them the floor whenever they're ready.
Hey, thank you everybody for coming. My name is Mark Suter. I'm a teacher at Elida High School in Ohio. And
my name is Preston Lehman, and I'm a senior here at Elida High School.
And so I'm just going to go ahead and screen share the slide deck, and I also have a link to the slide deck. So let me share this. All right. So there's the bit.ly link /VR Sims. Basically, we've been doing VR for the last 3 or 4 years. Actually, your older brother was kind of the christening with the change a tire car app. And the biggest tie to the real world for us has been doing training simulations. And so instead of just doing VR for entertainment is great. But where we're seeing a lot of connections in the real world is companies that are using it for training simulations. So when you're first starting out in VR, you're faced with a lot of questions. For instance, what headset are you going to use? What software are you going to use? And so I wanted to quickly go through some of the options that we've tried and what we're actually using. We're ultimately using the Oculus Quest 1, and we'll probably get some new Quest 2s. But very quickly, the 3 main options as far as I see it is the Zoe VR is a standalone app or a plugin for Unity. And it's free for educators, and its big draw is that there's no code. And you could basically create quick, seamless interactions, scenes for VR. But if you want to start getting into more training simulations that you can hand code and do more features of VR that users are expecting, there's the 2 on the right. We started with VRTK, which stands for Virtual Reality Toolkit, which is what your brother used. It's a really great package, and it's got an active Discord channel, but it's only being developed by a couple of guys in England, and it's intermittent with its updates. So you don't know if there's going to be future support or if they're just going to get busy with it and just say, Unity created their own, so we're not going to compete with that. I don't know. The XRIT is what we're currently using. It's built by Unity, which is a big draw for me because we know it's going to be supported. It's going to have continual updates. In fact, they just released a few days ago their Create with VR course on the Unity Learn website. So you can go through that, and I got a few screenshots of that. I labeled it as a con that you do need to learn some code to do what Preston built and what he's going to show you in a little bit. But you can make complete interactions without any code. But the code just allows you to extend it and customize it a little further. Here's Zoe. I think or Zoe, I don't know. But all of the creation is done inside of VR. So you select a tree and then you place it. You can put in a planet and say rotate over 4 seconds. Throw the shovel down and it's got 3 options, right? So it's very limited options, but it is very quick to develop a VR experience. Now, VRTK, it first looks a little intimidating on how to get started, but their documentation looks like this. And you would take this line right here and copy that. And here's their documentation, which I'll show you shortly. But that line that you copy, every project in the packages folder has a manifest.json, and you have to paste in a few special things. So here's all these Tilia, which is VRTK, Tilia packages. And so you have to custom paste those in. So it's not quite as intuitive, and you do have to paste in the new numbers. If they update, you go and change the version there. Unity sees it and pulls the changes. So it works, and we've used it. And their tutorials are mostly text-based with screenshots, which works very well for some people. I went through most of theirs, and then I made my own YouTube playlist, which is also linked in the ending slide. I have a bunch of links to this stuff. So how to do that copy paste thing, if you want to use VRTK, along with all of those other videos on there. So you can take the chair, you have a little transparent looking chair that indicates what goes there. That's the snap zone. And you can set it so it will accept the chair, but it will not accept the cube. You can pick up both objects, but it will only accept one. You can also do this type of thing in the XRIT that Unity made. So it's kind of a match there. The teleportation is very similar between VRTK and the XRIT Interaction Toolkit. And now, especially since they released the Create with VR course that Carl Domingo hosts with some others, I don't think anything's going to top this because it's so interactive. He goes through the video and shows you exactly what to click and drag and all those things. So it's really well done. My students can go through this playlist on their own on the Unity Learn website and learn all those same things that I have in the VRTK playlist. But these, I think, are even a step simpler because they're native to Unity. You don't have to go messing with the manifest.json file and things like that. So this is the example scene that they have you make. And this is what mine looked like after I had made all of it. All these little blue boxes are little areas I can teleport to. You can pick up the racket and hit the ball around. They also have little side challenges at the end of each little mini chapter. And one of them was put a custom picture in one of the picture frames because they provide you like with these picture frames. And so I put a picture of my daughter holding some chickens. Of course we did in one of these picture frames. So if you have students that are looking to challenge themselves a little bit, they have like easy, medium, and difficult little side challenges that you can work with. You hang the hats on the hooks and all kinds of fun things. You can turn the TV on and off with the remote control. You can use the flashlight, and those are all interactions that you work through in the chapters. So if you're going to be using really any of those VR things in Unity, I highly recommend joining. There's a very active Unity education, Unity Teach group on Facebook. And there's, 1,700 members in there, people from, university level, high school, industry, all kinds of things. So if you have questions, you can go in and post in there and you'll get a bunch of replies. So I highly recommend, if you're going to be teaching this, is to become a part of that community because there's live events that get posted there specifically for educators. And there's also just good support, really. I mean, if people are like, oh, I'm getting 20 Oculus Quest 2s, how do I register all these with students? Typical things like that we run into that your everyday user may not run into. So I've had people ask, how do I justify this to my administration to buy 1 headset, 20 headsets, the computers to run Unity? How do I justify any of that? And the route that I've been going is, yes, we can create games and that's really fun, but it's an easier sell, to be honest, if you can tie it to things like this and show them, well, Walmart back in 2018 was writing on their blog how VR is transforming the way they train. And they were training, I think in this one, they were training how to use like you buy something online and it goes into this little lockbox. Then you show up at the store, you use the lockbox to open it, etc. And that was just using the Oculus Go. That's not even, 6 degrees of freedom. I think that's only 3 degrees of freedom. And then this was very convincing to me. This is one of the things that made me say, okay, I really need to get my students doing this kind of stuff. Is I was fortunate to get a grant from the Fund for Teachers group organization to go over to London to go to this ARVR World Conference. And Lockheed Martin, they make everything from fighter jets to giant battleships, all kinds of crazy stuff. And one of their higher ranking guys that wears a suit was doing this little demo, and he didn't provide his slides, but I did sneak a little video of his presentation. And I thought, this is exact same stuff that we could be doing. So I don't know how this will show up on a Zoom video, but you can look at the video later. Basically what he's doing is testing the reachability from sitting in that operator's chair. Can I do things and push buttons and reach everything I need to reach? And judging by the screens, this is some sort of console for either running part of the battleship or remotely advising and mapping. So after I saw that, I thought, first of all, my students can build this exact thing, putting pictures onto 3D models to make the screens, and we could do this kind of stuff. And so I started thinking, why don't we just reach out to local companies and say, hey, here's some stuff we've made. Of course, you make some stuff first. And you say, here's what other companies are doing. Will you allow us access to your, just to come into your company, like to your factory, to observe what your manual labor workers are doing, whether it's a console or assembling car parts, and will you let us make a prototype for you? You don't charge them for it, but the end goal is not to make money. It is to get these students experience in a real world situation. And they're not only learning how to build a VR experience, they're developing what arguably might be just as important or more important, the soft skills. They contact the people after, I might help make a connection, but they then are going back and forth on the project with them. And so that's a very realistic, fairly simple way. If you went through the XR Interaction Toolkit course that's on the Unity Learn website now, you would be able to make what Preston's going to show you and this that Lockheed Martin is using or was using at the time. This was in 2019. You'd be able to make those things, and so would your students, without that much work. It looks like it from the outside, but once you get into it, it's really not that much work, especially if you go through the course and learn how to do those things. So that's a really easy, a much easier sell to administration, is to say, we're going to get these students real world experience by tying in local companies. And if you don't know where to start and you're like, who am I going to contact? Contact your local chamber of commerce. Tell them what you want to do and say, who do you think might be good at this? Is there any manufacturing where people are, doing a repetitive motion type thing that hasn't been already taken over by robots, right? But even how to run the robot, you could even do something like that with button presses like you saw in this video. So those are the kinds of things that we're doing. Whoops. Let's move on to that. And this is the last slide, and then I'll turn it over to Preston. I just went to see what the AR and VR World Summit Conference is doing this year. And this is some of their speakers from last year. I just took a quick screen grab. And I thought it was interesting that some very recognizable organizations like the Red Cross, they have an entire unit doing virtual reality. I don't know what, they don't have a link to his stuff, but I thought that was intriguing. Northern Ireland Tourism, they might be doing like virtual presence things like, well, here's what this castle used to look like, and you can walk around that 3D modeled castle in VR. I imagine that type of thing. And that's another fun things your students can make. And really, this Farouk is working with the Ford Motor Company. And actually in our where we live here, we have a Ford Motor Company F-150 engine plant. And Preston's going to talk a little more about that and also give you a demo of what he created. So I'm going to switch seats with him. Scoop right up.
All right. So, as you said, my name is Preston, and I'm the one that made the VR simulation. So it all started a while back before we watched this whole General Motors video. We'll get to that. But last year, we talked to Ford, and I was the head of the VR development team here at the Elida High School. So we talked to Ford, made a team, and we were going to actually go over and tour the plant, take pictures, and tell them what we could do, like set them up and kind of develop a whole plan to make a simulation particularly for them. So we had all that ready, and then of course COVID hit. So it got shut down. We couldn't go into Ford, and just like that, we were stuck.
Yeah.
So yeah, a whole year passed, and I come back, and now I'm in game design. And Mr. Suter talked to me, and he was like, hey, so we should get back onto this simulation idea. And he showed me this General Motors video of how they're sending wood cutouts through an assembly line and just doing simple like tasks like bolting pieces of wood onto the already wood structure. And I was like, we could easily do that. And we could make it VR. We could make it deployable. We could get it out there. And so that's kind of what started this whole precursor to making the VR simulation. And so, yeah, here you see the wood boards and stuff, and they're drilling them on.
Yeah, they have to pick the right part from that list of boards.
Yep, and they have to put the hex nut on and then bolt it down. So, as all things start, we paper prototyped, which actually isn't paper because, you know, we're fancy. So we 3D printed this model of the car, which is the actual model we use inside of the VR simulation. And we have a 3D drill here. And so pretty much what we did is we came up with the idea that we would snap the board into place, put the hex nut on. I don't know how good that is to see, and then drill it on with the drill.
We do the paper prototyping specifically because it takes long enough to assemble it in VR that making it out of cardboard, paper, 3D printing, whatever you have laying around, you can do that in like 1 or 2 class periods. And then they'll spend the next, 3, 4, 5 weeks building it. So it's a lot faster to figure out, well, let's do this, then this, then this. So it helps you visualize.
It does. So, yep, you place the part on. I forgot we put these.
Yeah.
And then you screw it in, use our beautiful drill, and then it's finished. So early in development, I was using VRTK. So I went through the whole tutorial and learned everything. Well, not everything. I learned the basics. And so what I did was set up this little test scene where I did basic interactions like grabbing a cube, grabbing a sphere, making it snap to a certain position on my hand, or just making it grabbable anywhere. And then I also set up snap zones to where the objects can be dropped into a certain place and they're stuck there until you grab them back out. And so this is super useful for like putting the board on the car or putting objects back into a certain place, or like if you have to disassemble, let's say, an engine, you could disassemble it, and then these snap zones would help you put them right back into the same place. And you can make that a certain order as well, which is super useful, and it's just crazy. So this is what my original concept kind of looked like. That little orange outline on the car is where the board would snap into. So I had the board snap into place, and then I could kind of interact with it and mess around with like the positioning and where I want to put the bolts and stuff. And then eventually I had to switch over to the XR Interaction Toolkit. So that's the newer Unity developed, and it's going to be much more documented, I feel like, as he was talking about. They already have the tutorial out. And so I had to switch everything over. And that didn't take too long. The tutorial is super easy to follow, but I reset everything up. I even added a UI, so you could put a welcome screen, you can put settings, you can put directions. And the main problem with switching over was I had to relearn what like the snap zones were and how to make objects grabbable and how to make certain objects interact with other objects so they wouldn't fall through the floor or just disappear off into space. So here's the board and the 2 hex nuts that I have. And then the first direction is to grab the board and place it on the car. And then once you place that on the car, those directions disappear and it will actually replace the directions and tell you to grab the hex nuts and put it onto the car.
I didn't teach him any of this. I said, good luck, Preston.
He kind of just threw me out there. So
I showed you the tutorials.
It's definitely, yeah.
You're welcome.
Thank you. So this is, yep, here's the second set of directions. It goes directly next to your eyesight because you don't want it too far out of place, but you also want it to be kind of out of the way so people can see. And this just helps people get guided through what they're supposed to do because you don't want confusion. You don't want to just throw somebody out there because that's not how it's like in the real world. Directions will be explained to you. You'll be told what to do. So then in the end, this is kind of what it looked like. It's a little fuzzy because the resolution was bad on the screen capture, but I added in a drill so I can bolt the hex nut down into place. I added second boards and a third board that actually won't snap on. So that's a big part about the snap zones as well, is you can make it conditional. So only certain objects can snap into place. So I can't accidentally snap the hex nut into where the board is supposed to go, for instance. And I added a teleporting target around near the bottom. So if you drop something, you can move around, you can teleport around, but you can't teleport too far outside of the zone because you don't want people to just go crazy and go all over the place. And some of my eventual goals would be to say add a lever that will actually move the assembly line and move the car, which, you know, it's a stretch goal. I couldn't make it in time for this. I wish I could have. And so people can speed it up or slow it down if they think they can't get the board on fast enough. I would also like to add a timer that's going to be on the screen and it will save your best time. And so you can kind of like challenge yourself to go faster, go slower. And eventually it'll just keep repeating the car. So the car will get to the end, and if the board and everything is on correctly, it'll say good job. And if it's on wrong, I don't know, we'll fire some alarms or something. It'll just blare in your ear.
And this is the point where if we were still able to work with Ford, and they, by the way, they still are excited to work with us on something once we can get in there. This is the point where you take this prototype and you take the Quest headset over to them and you say, okay, trainer, developer, can you try this on and try to see what this feels like? Is this realistic? What should we add? What should we take out? And because if you go through and you spend too much time in this, you end up working on things that aren't actually going to end up being used anyways. So he did a great job getting to this point. And then, like he said, the stretch goals would be the moving of the manufacturer of the cars. So the next one shows up and you almost start to gamify it in a way, really, and see how many cars you can get. How fast can you get the thing to move before the cars start to disappear and stuff like that. So,
yeah, a big thing is you want it to be directional. You want it to help teach people, but you also don't want it to be too realistic. Because once you make a game in VR too realistic, it kind of makes you lose a sense of reality, honestly. So you want it to be kind of these low, not super high res objects, and that slows everything down and makes you feel really weird. Yeah, it actually looks better in VR. And so, and as well, I kind of had to develop this whole thing by myself, whereas last year I would have had a team to help me develop everything, and I probably would have gotten farther along if I would have had them during this part, but it wasn't too bad. I got through it. And
I would like to, when we start working with Ford, to go there and actually, if they had a training module like this, to actually like have Preston, without any training, do their training to see, does it transfer basically? And then you could have them start to train their employees by saying, okay, first you're going to do this experience in VR on the Quest, and then you're actually going to go to the factory, and can you do it without any interaction with the trainer? That really shows you, did the knowledge transfer from virtual to the real world?
Yeah, and doing VR training is way cheaper. It's way faster and easily upgradable. If you have to switch something in the assembly line, you have to remake the whole assembly line. For this, all I have to do is add in a few objects and change a few scripts, and I can change how fast the drill goes or change where the bolt snaps or anything like that. It's so much easier to change than in what a real life setting would be. So it's just a much better option to real life training.
We'll say. Live?
Actually, I only have a few more problems to talk about because I don't want to make it seem like it's all, all perfect.
Everything went perfect.
No, some of the big problems I had was trying to get the drill to interact with the hex nuts once they're in place. And I still couldn't figure it out by the end. So I kind of took a cheap route and did it a different way, but I'll explain that once I'm in the live stream of the game. But pretty much I was trying to get the drill to press onto the nut and then twist the nut onto the board, but they just wouldn't connect with each other. I would try to debug .log, to make sure the interaction was happening, but no interaction was happening at all unless you let go of the object, which didn't make sense to me. So I'm still trying to figure that all out. But pretty much what I did was, instead of interacting with the object in the snap zone, I'm deleting the original object and replacing it with an object not in the snap zone.
Little sleight of hand.
So to you, it looks like it's still snapped, but in reality, it's not even the same object. Yeah. It's completely different. So that's one of the problems I had, was trying to get those snap zones to interact. But other than that, it was all good. Looks good. Sounds good. Let's show them. Live demo time.
It's all you.
All right. Let's get this on. It should be back here. Yep, the boundary's back here. So
I'm going to get out of your way.
Hopefully this doesn't catch you.
Ready?
Right here. Perfect. Hopefully it's still connected. Yep. So this is the world. This carpet right here is where you can teleport around. When it turns white, it says you can. So I can pull the side grip and it'll teleport me right over closer to the table. So these are some of the other boards you can grab and interact with. That's not going to fit. So you don't want that one. That's not going to fit. You don't want that one. You grab the one that fits, put it right up to it, and it's snapped in place. See the directive changed right here. Next, you grab the hex nuts, put them into position. Put the second one into position. Go on and grab the drill. Looks pretty good. You just put it right up to it, bolts it down, and it won't go any farther. Bolts it right down. Nice. It's a little big, so there's still some, sizing issues, and I want to make it so on trigger, I'll be able to, instead of just pushing it up to it. And we'll add some sound effects and some vibration.
The haptics, yeah.
The haptics, and then my welcome screen. And another stretch goal is to add settings, which I'm not sure what the settings are going to be, but they're there. You can enable them and disable them, and the check mark will go. There we go. Yep, you can enable them and disable them, and that can interact with the world as well. So
good.
Cool.
So how long did this project take you?
This project, I really started buckling down about a month and a half ago, probably. Yeah. The beginning was learning the interactions and looking at the video to make sure I got everything right.
So from the teacher perspective, he's in the game design class, which is, we do some Unity C# and making either 2D and 3D games. And I offered it up to anybody. I said, does anybody want to do VR development? Go ahead, you can take it over there. If anybody wants to do VR development, I'll exempt you from the other assignments and I'll just grade you on this single larger project. And so Preston took that on, and so he comes in every day and works in the VR project. So we're ready to open to questions, I guess.
Stop share.
Leave it on. Are there any questions?
We turned it down.
Oh,
There
sorry.
we go. Sorry.
We turned our volume down. Sorry.
Oh, okay. Well, that's fine.
Oh, I'm so sorry. That's because it's a different window. Let me stop this and play it again.
Part 2. We back up into the boundary.
Oh. Can you see it now? Excellent.
Sweet.
Sorry about that.
So yeah, the white line indicates that I can teleport around. So I have these snap zones that make me look in a certain direction. And I have this whole carpet that I can teleport around onto because I drop a ton of stuff on things. So, oh, we lost tracking. It might be, yep. Okay, we're back. So these are my different boards. You grab this one, you'll realize that it doesn't fit. You can grab this one. You realize that it doesn't fit, but okay, of course it does that. So the other board snapped into place. That hasn't happened to me yet, so it's really weird. But once the board is snapped into place, grab the hex nut, teleport over because I'm a little out of space here. Place it on. Grab the second hex nut, place it on. Grab the drill, and once you put the drill up, it'll start drilling it down, and it stops right once you get to the board, so it's like you're actually putting it on. And the same for the other one. And then, ta-da.
Ta-da!
And then, yeah, these are the settings. You can go in here. I don't have any of them set up yet, because I'm not 100% sure what I want them to be, but you can check them, uncheck them. And that will change stuff in the game. One of them is probably going to be the timer that I'm going to add later.
Yeah, the timer, score, start, stop, the motion of the cars, like there's one car after another, like an assembly line would be in constant motion. Those are all kind of stretch goals, but at this prototype stage, this is where you go show it to them.
Yep.
To the client. So now we're open for questions. Sorry about that.
Air mask on the wall.
Okay. What industry is fun to imagine being in VR? What would you think would be a fun industry to transition into VR?
I think I can't think of one really that you can't apply it, because there's always visualization, like urban city planning, placing buildings, those kinds of things. Any kind of like welding. I know there are well-made welding trainer softwares out there, but disassembling and reassembling things, like an electrician, that's a dangerous thing if you get it wrong. So dangerous scenarios are really good for VR because you can get a lot of those mistakes out of the way. So if you're learning how to wire up a house electrical system and replacing fuses and what wire goes where, that's a good thing for that. I had a student last year, 2 years ago, do how to fuse fiber optic cables. There's a special little device. So you open the lid, you put them in there, etc. But even if they're not assembly type fields, there's always the visualization. Like you saw the one guy from, I think, Ireland or something. Like you could show a reconstruction of a castle from the 1400s that isn't there anymore. So people can visit that and walk around it or teleport around it, interact with characters in it or whatever. But I don't know, it's just kind of fun to even brainstorm about it. What do you think?
Yeah, so I am actually pursuing the job of becoming a neurosurgeon. So I'm going to college to become a neuroscience or for neuroscience. And one of the biggest things I've seen right now is VR for mental health. And what they do is they can actually put a therapy program into a Quest and send it out to somebody's home. And the person will put on the Quest, use the controllers, and a little therapist will guide them through an interaction. Yeah. They've used it for phobias, PTSD. They've used it for anxiety, and they actually have really high success rates because they're able to trick your body into thinking you're there, but your brain kind of knows that you're not. So for phobias, it's crazy how fast you can turn over and help somebody work around those problems.
Or you can make a VR simulation of doing a Zoom call.
You can do that.
And all its technical difficulties. Another question we got, they wanted to know, again, how long did it take you to create this project from start to finish?
So I mainly worked during school. So that's 5 days a week, 45-minute periods for about a month and a half. And I could have gotten it done earlier if I hadn't hit a few of the snags, like the snap zone problems. I probably could have had it done in a month. But this also isn't as flushed out as, say, a huge company would do, but it does the exact same job as what theirs would do. It still trains you, and it still gives you the experience of working the assembly line. So, yeah.
So about 30 hours.
Probably 30 hours.
Do you have plans to expand upon this project, or are you going to move on to other projects?
This project is kind of my main focus right now, like getting it to move down the assembly line is the next part I'll try and get to. But I would also love to get into not necessarily simulation, but more open kind of touring type things. Like my dad runs a construction business, and I wanted to model the houses that he would build in VR, and then the client could walk through the house and be like, oh, I like this placement. I like how big this room is, or something like that. That's another great application would be house tours and stuff like that. So
after Preston graduates in a month, next school year, if we can get into the Ford plant, I plan on taking this to them without any modifications and just say, here, try this, because most people at most companies are not going to have tried a Quest or anything. And so they're not going to know what it feels like or what it's capable of. So letting them just try this is going to spur their imagination of, oh, well, we could have you make a simulation of, and it'll just get them thinking, because it's hard to describe to them to just say, oh, here's some things you could do, but letting them try it out will really, I think, create a variety of simulations. And then we can have different student groups creating different applications.
All right. We want to thank you again for participating in CSGC 2021. And remember those projects, we do have student competitions as well. So you could always submit those to our competitions next year as you complete the simulations. We have a simulation category as well as a digital games category. So we'd love for your students and Preston to submit those to our competition. And we appreciate your time today presenting. Is there any way if our viewers wanted to contact you for more information, how could they get a hold of you?
Yes, I could just put my email in here. Can I do that? Just put it in chat. Would that work? Chat. There's my Gmail, Mark A. Suter at Gmail. And these are it's bit.ly/VR Sims. That'll get you, actually, you can get a GitHub, the actual Unity project that Preston showed you. You can download it and try it yourself. We're giving you the entire project via GitHub. Just download it and unzip it and run it. And some other links that we mentioned throughout. So.
All right. Thank you again. We appreciate you guys taking time out of your day to be with us today.
Thank you.
Thank you.
Bye.